Welcome to today's webinar, Unifying Security Operations with Elastic. We will walk through the entire workflow from data ingestion to threat response. I'm Sandhya Ramamurthy. I'm the product marketing engineer at Elastic, focusing on Elastic security solution. So prior to this, I was technical marketing engineer at Cisco, focusing on their XDR, EDR solutions. And then in my career, I spent considerable amount of time as software engineer in the networking space. So the agenda for today, we will talk about the platform benefits. Elastic Security Solution is built on top of the Elasticsearch AI platform. So because of that, we have some benefits. We will review that, and then we will dive into the security use cases that we help to address. And also, obviously, there's a demo. This is going to be a demo intense webinar, so gear up for that. And we will also walk through the next steps. So this is the architecture for Elastic Security. This is a little complex, so let's break it down. So Elastic Security is built on top of the Elasticsearch AI platform. So what that means is the way we handle data inside of the platform, like the way you ingest data, store data, search through the data, that is all common across the different solutions that is built on the top of the platform. So in the security context, so when your data is present on a specific geographical location, because of the data sovereignty reasons, you have to keep it in specific cluster. So Elastic search platform allows you to search through the data wherever the data resides without the need to bring it closer to the central location, without data backhauling and all that additional charges incurred and so on. So this is one of the feature that is provided by Elasticsearch platform. Similarly, on the concept of searchable snapshots. So for example, if your data is present in a low-cost storage options, and if you have to search through the data, for example, if you have a firewall data which is for stored a 6 months old data that you have stored in a low-cost storage options, and you have to search through the data for looking for some occurrences of APT attacks, then you can use the searchable snapshot concept and search through the data from a single platform without bringing in data, without rehydrating the data, and so on. So we can let the data sit where it is, and then we can search through the data. And similarly, the concepts like serverless deployment and the open and transparent ECS schema, all of this is by default available to Elastic Security. On top of that, Elastic Security is going to focus on your security data to achieve and solve different problems. So for example, if you want to detect some threats that is present in the data, because we have that rich data set, so we are able to detect threats in real time. And also we can detect anomalies in the data that you have ingested. So we have machine learning jobs, which are customizable and which allows you to discover anomalies in the data that you ingest. So, and for example, when you're bringing in your data, it could be your EDR data or your network or firewall data. So we are able to achieve correlation and achieve an XDR outcome by doing the correlation in the same platform. And then we also have our native protection, which is our native EDR, which is which helps to solve different problems. Like you can stop different threats, like malwares, ransomwares, memory-based attacks, threat injection attacks. So this is across different operating systems. So, and also the agents that we have deployed in the cloud, this helps to bring in additional telemetry like posture findings, vulnerability findings to Elastic Security, which can be used for different outcomes. And of course, AI is sprinkled, generative AI is sprinkled in the product at different workflows to bring in efficiencies in different workflows. And lastly, the response capabilities. So with our native EDR, we are able to take response actions like running a OS query, for example, or if you want to isolate a compromised endpoint. And not just that, even if you have a different EDR, for example, SentinelOne or CrowdStrike, you can still take response actions from our platform without tool hopping at the time of incident. And also, if you want to expand your response options, you can take response against different elements of your ecosystem, like sending a Slack message or raising a ServiceNow ticket within the same platform. So we have integrations with Time's workflow, so that way we are able to take response across different elements of your ecosystem. So now let's quickly review the end-to-end workflow, starting from how we collect data, ingest data to the platform, and then how we take response actions. Quickly review all of the capabilities, and then we will dive into the demo. So the first obvious step is collecting data. So we have out of the box integrations that helps to bring in data, onboard data to our platform. And also this data is getting normalized. So this helps to maintain the agnosticism of the platform. So it doesn't treat a specific firewall data, in a different way. It's going to treat everything in the same way. So this is what normalization is, and that's done in the platform automatically. In this part of the workflow, we have a generative AI powered feature called automatic import. So for example, if you don't have out of the box integration, and if you have a specific custom application and you want to bring data from that custom application to Elastic platform, you can use this feature. So basically what it does is it's going to create the ingest pipeline for you, so that you don't have to do the manual work of creating the pipeline. And without this, actually that process is really time consuming, and it is also prone to errors. So that's what we are trying to solve with the help of this feature. We will see this feature in action in the demo, but just keep in mind. So, and also enriching data inside of the platform, we try to add context to the data wherever possible. So, for example, if we have intelligence from a specific, threat intel feed that we have, we add the context then and there. So the next obvious situation is whenever all your data is inside. Now it is important to detect threats in that data, right? So what we do here is we have automated detections, that is pre-built detection rules from given by Elastic Security Labs. So we help to detect threats in your data. So for example, if there is any occurrences of a specific LOL binary attack, or if there is a partial doing something malicious, or if it is specific ransomware attack, so we try to detect all those automatically. So that's done through our pre-built rules. So, and also there are custom rules that you can write, and it is flexible. And also, as you can see, this is a very transparent approach that we follow. That means the detection rules are not a black box, so you can see what exactly each and every rule is doing. And of course, we have machine learning jobs, which helps to determine the anomalies present in the job. So, for example, if you want to notice a spike, in a specific authentication errors, or if you want to keep track of a specific data and look for anomalies in that data for unusual process that is running in a Linux machine, for example. So you can create machine learning jobs that are also pre-built machine learning jobs. And of course, threat hunting, it can be really easily done in our platform, because we have access to that rich data telemetry, right? So we are sitting on that rich data, so we can do different types of threat hunting, like proactive threat hunting, reactive threat hunting. So we have access to all the data. So that's one of the advantage at this point. So once we discover some suspicious behavior, obviously you're going to be notified of them, and this is going to be notified in the form of alerts. SIM is always known for its noise, right? So there could be alert fatigue, and we are trying to solve that problem with the help of a AI-powered feature called Attack Discovery. So what this does is it's going to take in all your alerts, and then it is going to check for correlation in that alerts, and then it is going to give you a neat summary, like explaining why it thinks that the specific alert is dangerous because it is following a specific attack chain and all that information. So imagine like you have 100 alerts, and now you have a discovery that is telling you all the important bits and pieces, like entity involved, the host name involved. This is really helping you look into the incident much quicker, so that it is trying to help you focus on the most important one. And of course, the timeline. This is within the same context, when you are having a discovery, when you want to do a investigation after a discovery, you can use the same platform to do your investigation. So you are able to query any data, whether it is data which is residing in the same local cluster, or it is in a remote cluster, or it's the data is in a frozen environment, doesn't matter. You can use the timeline view to hunt for threats after a incident or after a occurrence of a incident. So the important thing is, this is going. You have to use a lot of ESQL queries, or some cases it is going to be really difficult to understand what we need to do after a particular incident. So we have AI assistant in our product that will help us, to give you different answers at any point of the workflow, right? So you can ask questions like, can you give me a ESQL query that can help me hunt further for this particular discovery? Or you can ask questions like, what is the remediation step that I need to take for this particular discovery? So the way our AI assistant works is, it is little different from the way how the chat GPT or regular chat interface works. Here, whenever you submit a question, so you're not just checking the public internet data to give the right answer. So we have a concept called knowledge base that is added to our AI assistant. So this is running on a concept called retrieval augmented generation, which is powered by Elasticsearch Relevance Engine. So what happens is, whenever I submit a question, so I can add some business data as my knowledge. So when before submitting that question to LLM, that context is fetched from that knowledge base. So I can explain this better with an example. For instance, if I have on-call data that is specific to my organization and that's specific to my business, right? So at the time of incident, when I'm asking a question like, who is on call today? Who should I reach out to? So that LLM is going to give you an answer based on your knowledge base. So the knowledge base can be anything like your wiki or PDF information, your videos, tutorial links, or for example, if you have a specific playbook methodology that you want to follow during an incident. So all of that can be added as a business data. And then you can question the AI assistant at the time of incident to retrieve the answers from that context as well. So this is something quite different, and we will see that in the demo and see how it is useful. And lastly, the response capability. As I said, from the same platform, you're able to take response actions. So it could be isolating for for containment actions, or if you want to take kill a process, or if you want to check for execute some commands directly on the endpoints which is compromised, you can do so directly from our interface. This is the same platform from which you can take response action. So even in this example, I'm showing that on a Sentinel-1 EDR, you can take response actions directly from the platform. So we will see all of this in action in the demo. And this is the last part, which is extending the response capabilities further. So SIEM is incomplete without the SOAR counterpart. So we are able to extend the response operations with the help of Time's workflow automation. So now we will jump into the demo. Let's start with the first part of the workflow, which is integrations. Like as I mentioned before, we have 400 plus out of the box integrations, and we have security integrations, roughly around 200 security integrations. So, for example, if you have a specific EDR, if you want to bring data from a specific application, so you have different out of the box integrations. So what if you have a custom application and you don't have an integration? So this is the AI powered feature that I mentioned. So here, in order to do that, this is how you begin. So basically, when you want to create the integration, you have to specify your LLM of your choice. So now I'm going to choose this. And then all I have to do is specify the name and the description and the logo for that integration. And all I have to do is just bring in a sample log file from that application, so which has all occurrences of different things in that log. So once I have a log, sample. So for example, I'm going to select this as a file stream. And then if I pick in the log that I want, which is Fifth crypto application in this case. So all I have to do is hit analyze, and fast forwarding it, I will get a integration like this in minutes. So this is the ingest pipeline that is created by AI. So it has done all the normalization, ECS mapping, everything, and it has given me this result. I can go ahead and edit my pipeline if I want, or I can directly go ahead and add it because this is validated anyways. So that means it will start ingesting data directly to the platform. So this is one of the ways that you can onboard your data source. Awesome. So once this is done, so we can go to our next step, which is how do I visualize, or how do I search through all data. As I said, in our platform we are able to access the rich raw telemetry, so from all the sources that you ingest. So you have access to the raw telemetry here. So I can look for anything and everything using this specific discover view. So I can also write my own SQL, and then I can, for example, specify the event action or the event type or anything of that nature. So I can look for a specific data directly from this view. So now when I have to, so the other option is I can directly go into the dashboard view. So we have different ways to visualize the data that you ingest. So on the security context, we have different dashboards that are pre-built dashboards that are readily available to you. So for example, whenever I search, select this is a pre-built dashboard. So this is giving me the posture information collected by the Elastic Defend agents. So you can see that this is collecting data from AWS and GCP and providing that to me. So going back to the other dashboards, so we have dashboard specific to entity analytics. So this will give me all the information about the user, the host involved, the services, entities, and different things that is used in my environment. So this is an entity analytics dashboard. And of course, this is again coming in from the agents that we have, our native agents that brings in the vulnerability information from the cloud infrastructure. So for any integration that you add, automatically you have some pre-built dashboards. And of course, you can create your own dashboards. So this is on how to visualize the data. So next step is obviously finding anomalies in that data. So we have machine learning jobs that helps us to discover anomalies in the data that you ingest. So for example, if I go into the jobs here, I can see that there are some pre-configured jobs that looks for different specific anomalies. For example, in this case, it is looking for an unusually large spike, successful authentication events, and so on. So now, if I want to specifically create a machine learning job, I can do so as well. All I have to do is specify my index, that is the data source. So in this case, for example, if I choose CloudTrail, then it is going to tell me that these are all the pre-configured jobs that are available, and then I can use this wizard to create my machine learning job. So now, for example, I'm going to pick this, and then it is going to ask me whether I should use a particular time range or should I use the full data, and then I can go ahead and choose the fields that I'm interested in. And then in this easy interface, I can set up the machine learning job details, and this is going to run and look for anomalies in my data. So now all I have to do is specify the title for this. I have already created this, but I'm just going to show how this is done. And then, so when I do the validation, it is going to say, yes, this is good. And I can go ahead and add it to my jobs, list of jobs. So once I have this, I have an anomaly explorer. This is going to show me, the job that I just added as well. So basically, it's going to show all the anomalies that was discovered in the form of a heat map. So now I can see which job, exhibited anomalous behavior, and I can look into the details like threshold, the anomaly score, and everything from here, and also the top influencers from here. So this is, the anomalies. It is reporting on the anomalies. but what if you want to be alerted on this anomaly? So for that, we can go into the next topic, which is called the detection rules. So here, by default, our solution has default elastic rules like detection rules. We have around 1,377 rules supplied by Elastic Security Labs. So we have this is across different data sources. It's not just EDR specific or firewall specific. So you have these rules are across. It's looking for suspicious behavior across different data sources. So now, for example, if you take a specific rule, for example, so now you can see different information here. So this is all very transparent to you because you can see what exactly that equal query is, what is it looking for, and everything, and even the MITRE attack information. All that is being added here. So it is very transparent. So you know what it is looking for. So if there is a false positive and you want to fine tune this, you can go ahead and do that directly. You can create a duplicate copy of this, or you can go ahead and edit this rule directly. So when I say, when I go to the action section of the rule, so I can tie it to any specific action that I want to take when that rule gets executed, and all the details about, the MITRE mappings and everything associated to the rule is recorded here. So for example, if I have to create my own rule, that option is also available. So there are different ways I can create a new rule. So this is like, for example, I can use a custom query or machine learning or ESQL. So at the time of investigation, when I found some specific, timeline thing, investigation that I need to add it as a rule, I can go ahead and add it directly. And then, for example, machine learning job. So for example, we created the machine learning job before. So if I want to create a rule to notify me of some anomalous behavior that job has discovered, then I can specify that machine learning job here. And then I can set the threshold and so on from at this point in order to notify me if that specific score has reached or not. So these are all the different ways that I can create the rules. And of course, you can go ahead and look for the MITRE attack coverage from here. So for example, we have, going back to the rules, so you have this MITRE attack coverage to see how much coverage you have in terms of, the MITRE attack framework. So you, based on your enabled rules, whether you have enabled certain rules or not, so you can see the coverage that you have. So this is all different ways to, add rules and check for, your coverage and so on. In this interface now, for example, if you have rules in your legacy SIEM and if you want to port this to Elastic Security, so what you have to do for that is we have a feature called SIEM rule migration. Again, this is an AI part feature that I want to show. So here again, you have to specify your LLM model of your choice, and then you can begin your translation. So all you have to do is, for example, now I'm going to upload, click on upload more rules here. So if you see that in this case, I'm using Splunk rules as an example. So all I have to do is bring in that information from Splunk interface. And then this workflow is going to tell me that if I'm missing specific macros in that rule, and if so, it is going to prompt me to upload those in the next step. So once this is uploaded, then I'm going to upload the macros specific to those rules. And then, so if I add those and then hit on upload, so now I can hit translate. So what happens is during the translation, so we can review the translated rules, which are already translated. Let's look into those. So as part of the translation, couple of things happened. So whenever you see, specific Splunk rule, it is going to check whether there is a matching elastic rule already written. And if that is the case, it is going to give me an information that, hey, I'm going to pick this rule because the intentions are the same. We are looking for the same thing. So this is already installed because this is it's matching to the pre-built elastic rule. So in some case, when I have, for example, a translated rule, that means that specific rule was not available in Elastic because it was custom to your environment. So what the AI feature does is it's going to convert everything into a ESQL format, from translating everything from your SPL format to ESQL format. It is going to give you the transparently everything related to this translation. It is going to let you know why this was done in a certain way, and all that information is provided here. And so if you are, if you want to make some edits, you can go ahead. If you're happy with this translation, you can go ahead and install. So similarly, if there is any partially translated rule, that means we are missing some specific indexes. That means we have not added all the data sources yet. So probably that's why it's saying partially translated. So this is the fastest way, to onboard your rules from your legacy SIEM to Elastic. So once you have all the rules, obviously the next step is, getting notified about the suspicious behavior. And we can see this is the alerts view. And I think the SOC analyst would probably start his investigation from here. So here, this is the alerts page. I can look for a specific timeline. As I said, I can even look back in time and find if there are any alerts in that time range or not. And then, so as you see, there are some specific alerts. Now I can filter by this particular host, or if I want to specifically look for a more details about a specific alert, I can do that. And then now if I go to this view, I can group here by the rule name here. So in this case, this is all the EDR alerts that are coming in. So as you can see, I have that clear idea of what is happening from this event summary view. So also, if I want to look into this particular alert, for example, if I click on the analyze graph, so it's giving me the parent-child relationship of the processes here. So I can quickly understand what happened. Like, for example, the bash has executed certain things, and gzip happening, and some process got terminated, and all of this information I can view quickly. And also I can actually look into the session view. That means everything that happened on the console is actually captured. So this is really rich raw telemetry that's useful for investigation. So now at this point, it is, so now I can clear this filter. So now I got a quick idea of what happened, but still I'm not able to correlate all of this from this view because I have some alerts triggered on the AWS side, as well as I have some EDR alerts. So now it is a little overwhelming to understand what is happening right away from this environment. So now, with the help of attack discovery feature, I'm able to correlate these alerts. So this is again a generative AI part feature. I can specify my LLMs here, and then I have to hit on generate. So what it is going to do is take in the alerts that we saw on the previous page and see, it's going to see if there is any correlation between the alerts that was reported. So in this case, it has come up with the discovery, giving me all information. It says that there is some compromise attack on this particular host, and then it is telling me what is the user information, the username involved. And if I go into this, I can see the misconfiguration findings that are reported by our different agent, so that is deployed in the cloud infrastructure. So it is giving me all the information on the failures and all this, which I can review, and all the context in place, and also the different source IPs and different IPs involved in this attack. So it also tells me what alerts contributed to this discovery, and it says that there is a CloudTrail log deleted, there is a EDR alert. So as you can see, there is a good correlation happening here between AWS and also EDR alert. So to give out this discovery for me. So now also there is a MITRE attack chain explaining what happened. So imagine without this, you have to parse through all the 76 to come to this point. Now with this feature, we are able to quickly start the investigation from this point and focus on this particular attack quickly. So now at this point, if I want to take a action, I can add it to a case. That means, you know, whenever I have to work with my team members, I can just add it to the case, and we can work together on the case. So all of the alerts, all of the summary details, everything will be added to that case automatically, so the context stays as it is when we are collaborating on the case. So that's basically one of the workflow that we can easily achieve here. I also want to show another example here. So this is another discovery that was made based on the alerts that we had. So here you can see that the alerts are coming in from different sources. For example, this is the data coming in from the Sublime integration that we have, and then this is coming in from the EDR. This is coming in from the network traffic data. So all of this has been correlated to identify this particular discovery, and this says exactly what happened in this attack. So, there's a compromised username, there's a email, suspicious email, and then that was executed. There is a suspicious DLL, and then there is a run DLL. With the help of run DLL, that suspicious DLL was loaded, and possible attacks related to that. And there is also connection made to a suspicious IP address, and so on. So all of that is quickly available to me for review, and I can easily understand the attack chain that is listed here. And so I can start my investigation or take further actions based on this discovery. So at this point, so now if I want to dig in further, as I mentioned before, I have access to the rich raw telemetry. So when I go into the investigate and timeline view, so I can pick my data sources, anything, for example, any logs. If I want to specifically search for behaviors like, if any log entries have, like firewall logs have this specific IP address recorded, so I can copy that into my this is the rule that I copied. Basically, I'm checking if this destination IP address was present in any of the logs, like especially the firewall logs. I can check, fine tune, and check, and then it says that there is a firewall rule. And so basically, from the same interface, I'm able to query everything. So now, if I want to check for the email data for some information, like whether any suspicious email was sent of this nature, if I want to query my email logs, so I can do so from the same interface. This is, I have access to all the rich raw telemetry, right? So now I can run this. It is going to give me information about this specific email address, whether this suspicious email was found in any other inbox, and so on. So this is what it is trying to get me. And this is also telling me what are the different emails that I got from that particular user, and what was the, whether it was outbound connection, or and so on, all these details. So this is really cool, but I know that this is a little complex ESQL query. So what, you're not an expert, and if you need some help, so we have AI assistant to the rescue. So now let's go into the AI assistant. So here, so the AI assistant works specifically, it is context aware, basically. So that means if I want information, further information on this particular discovery, that is what we saw here. So that means all of the related information is added as context to this assistant. So whenever I say use this, and then based on this discovery, can you give me recommendations or remediation steps, for example? So if I ask, how would I remediate and respond to this attack? So it's going to get back with the answer, so we can review the results that I ran before. So let's quickly check that. So this is the same thing that I ran. So how I remediate and respond this on this environment. So basically, this is the new answer. So now it is telling me that I can do all of these things, like for this specific attack, please do this, do the host isolation, and do kill malicious processes, retrieve and delete malicious files. Sorry, it's still printing. And then now it is telling me that I can remove the registry persistence that was found in the attack. I can further do, further investigations like this. It is as simple as that, because I can directly go into the timeline view that I showed you before. It's going to execute directly with more information. It's saying that uh, what is that specific email that I want to see more details about that from that logs. So it has given me a timeline query which will help me to do that. And so, for example, in this case, if I remove this altogether and then ask for you know to get me all the email logs which has this particular email subject, then it is going to give me results based on that. So it is so powerful because I have access to the rich raw telemetry. So now, continuing the investigation, so going back to the remediation steps that was proposed by the AI assistant. So I can use any of these ESQL to go and dig further, investigate more. So this is actually telling me how I can investigate further about the process chain or registry persistence. And the important thing to note here is, irrespective of where your logs are stored, for example, if your firewall logs or endpoint logs is stored in a different cluster, that also can be searched using this query. So you notice the colon here. So this means that I'm doing a cross cluster search here directly. So I can go ahead and directly execute this. This is basically fetching information from my local cluster as well as my remote cluster. So also, I can create a lot of prompts that I want. For example, can you give me a query that hunts for persistence, and I can directly do this. And also, I have other prompts, like, for example, I want to show this query. So let's run this query in this link. So as you can see, this directly ran. So it gave me a link, and I directly executed that query. And this result is published here. So basically, I'm able to hunt for the persistence across different logs, whether it is a remote cluster or local cluster, doesn't matter. It is treated locally, and it can run, I know, the query across both the clusters. So back to this now, on the investigation step that we did before, like when we asked for the response step, so we got additional information, like the resource and video guides, for example. So this is specific to my organization, right? And then I have additional recommendations, like, hey, go ahead and use this wiki. And then it is saying that this is a contact person information. That is interesting. And then also you can see that there is it is giving me options to block that specific IP on my firewall. So this is the Tines workflow that has been integrated here. So what happens is, if I open this, so it is taking me to the page action form of Tines workflow. That means I can directly key in this IP address, and then that specific workflow in Tines is going to get executed. So I can link all of this from the AI assistant. And as you can see, it is having information, like, for example, if I'm asking like simple questions like, who's on call right now? So it is going to fetch information like, Robert is on call for so and so time, and so on. So how does this AI assistant know about my organization's knowledge, and how is it aware of that? So that's where the concept of knowledge base comes in. So you can see that if I go into this knowledge base, I have added different things as knowledge to my AI assistant. For example, the on-call information, or specific, CloudTrail docs, for example. It can be on any format like PDF or a plain document, or if it could be even a elastic index that you can add as knowledge base, and your AI assistant can answer based on the knowledges that you have added. So that's what you saw in action here. So now let's go back to the assistant again. So all of this that you added, discovered from the AI assistant, you can keep adding to the case as well at any point. So you have options to add it to the case directly. So all of that you can add it to a case, So you can copy that and add it to the existing case, and whatever you find and discover, you can keep adding to the case so that can collaborate and work. So now the last piece is response. So how do you respond to a specific attack? So in this case, as I said, we without the need to do the tool hopping, you can directly take response actions on the EDRs, for example, the compromised endpoints. So here, if I look at this specific endpoint, now this is compromise. That's what we saw from the remediation also, that we need to isolate this host. So how do I go about and isolate the host? So here there is an action that takes me, if I say isolate host, I can directly leave my comment and then confirm that action, and this will get isolated. And then, for example, if I want to respond on this host, like do take some response actions, for example, if I want to kill the process or execute a command, upload a file, and so on, these are the options that I have that I can run directly on this endpoint. So now the next step is, since it is our native EDR, we can take response actions like running a OS query, for example. So here I can run a single query or a pack of queries on this endpoint, and then I can select the pack that I want. So this can be done as part of your incident process, like when you're collecting more forensic information and more information for your investigation, so that it can be done at that point. Or if you are going to check that if a patch is installed successfully, if a process is terminated, so you can use this at any point of your workflow, right? So now this is for our native EDR. So what if we have a specific EDR, like for example Sentinel-1? So how do I take response action on a Sentinel-1 endpoint? So here, this is the one that has this is an alert that was triggered by Sentinel-1. So now if I want to take response actions on that host, so this is the Sentinel-1 host, I can take all of the response action that I showed before on this endpoint as well. So this is one way that you can take response. So now I want to talk about the other SOAR capabilities and the response actions that we can take using Tines. So here, as you can see, this is the Tines interface. So with minimal coding, you can create this kind of a complex workflow. So this basically does many things across your different elements in your ecosystem. For example, it is checking a specific IP in a gray noise community, and then whether it is malicious, if it is malicious, then it is going and blocking that in the firewall, and then sending an email action, and it is querying Elasticsearch for that IP hits, and it is also sending the details to Elastic AI Assistant for more remediation steps. It's doing multiple things as an automation sequence, and this is one of the workflow that I can invoke at any point. Like for example, I can directly call from my AI assistant, or I can tag this to a action section of my rule, as I showed before. So now I'll show that again. So if I go into the detection rules, if I have a specific rule, and if I want to take a response action on that specific rule, so all I have to do is go into the action section and then specify my times workflow that I need to call for this specific for the specific rule. So for example, if I have this demo that I added, so this is the workflow that I showed before. So basically this is what will get executed as part of the action section of this rule, and then this will start executing this. And the moment next time when this rule gets triggered, this workflow will get automatically executed. That brings us to the end of this demo. So let's go into the slide view. So next steps, you can read our customer stories and find out how they are using our product, and the different use cases that you will find there. And also, you can download the Elastic Security Labs, which is at this specific location. And also, you can try Elastic Security for yourself. And we have a 14-day free trial. So, and also check out more information on these links. And yeah, that's about our webinar. That's a wrap. So I hope it was useful, and thank you for registering. If you have any questions, please reach out to us or drop them in the chat. Thank you.